Welcome to Unit 2, Lesson 11, Finding Intersections Practice Problems. Okay, what are the points of intersection between these functions? All right, so let's solve this algebraically. What you do is you set them equal to one another. So now I'm going to do a little math trick here. I am going to divide both sides by x plus 1. Because the x is factored out, I saved myself a little bit of math. Now I get x squared is equal to 1. And the square root of 1 is positive 1 and negative 1. So now, since I have two x points, I had to stick them back in to both equations to make sure they work. This is just like systems of equations. So let's start with sticking it in a g. So g at positive 1 equals 1 plus 1, which is 2. So our point is 1 comma 2. G of negative 1 is negative 1 plus 1, which negative 1 comma 0. Now let's check these points in F. So F of 1 equals 1 squared, 1 plus 1. 1 squared is 1 times 2 is 1 comma 2. It's the same point. So 1, 2 works. Let's try F of negative 1. Negative 1 squared, negative 1 plus 1. Negative 1 squared is 1. Make sure you put it in parentheses. When you substitute, use parentheses to keep your sign straight, which equals 0. So our point is negative 1, 0. So both of these functions have 2 points of intersections. We get the same point, 1 comma 2 and negative 1 comma 0. So if you was to graph both of these things, x plus 1 is a line that looks like this. X squared times x plus 1. All right, so they hit at 1, 2, 1, 2, and negative 1, 0. So right there, let's put this in different colors so we can see it. So these are the points of intersections. X cubed plus x squared looks like this. It starts low. It'll dip back down. It'll do something like that. So finding intersection, we're looking for the points of intersections between two separate graphs. Okay, let's look at problem number 2. So we see we got two polynomials here. We got to multiply. So we'll draw our distribution arrows to help us remind. When we got 4 terms, we have to get 4 products. We get x squared minus 2x plus 5x minus 10. We're going to set that equal to 2x squared minus 4x plus 1x minus 2. So we get x squared plus 3x minus 10, and then 2x squared minus 3x minus 2. We're going to subtract this whole polynomial on both sides by changing all the signs. To get it equal to 0 on both sides, basically you just change all the signs. Minus 1x squared plus 6x minus 8. We're going to multiply the whole thing by negative 1, giving us x squared minus 6x minus 8. I think we've seen the same polynomial in the practice problems. So this gives us x minus 4, x minus 2 equal to 0. So x equal to 4 and x equal to 2. So now we had to stick both of these into the equation. But here's the thing about taking standardized tests. If you got x equals 4, 418 must be one point and 20 must be the other point of intersection. How do I know that? My x is 4, my x is 2. There's no other positive 4 and positive 2 for my choices, so I can stop here. And this is the good thing about taking standardized tests. If you know the tricks, you don't have to do the whole problem. I can stop right here. But what you would do now is stick 4 into the first one, give me 4 plus 5 is 9, and then 4 minus 2 is 2, and 9 times 2 is 18. And you stick 4 into the second one. 2 times 4 is 8, plus 1 is 9. 4 minus 2 is 2. 9 times 8 is 18. That checks out. Stick 2 into F. 7, 2 plus 5 is 7. 2 minus 2 is 0, giving us 0. 2 times 2 is 4, plus 1 is 5. 2 minus 2 is 0. Again, 2 minus 0, so it works out great. Okay, what are the solutions to the equation? Okay, so now, what we have to do here, since it's equal to negative 15, I'm going to multiply these two. So x times x gives us x squared, so I got to distribute. X times 5 gives us 5x. Negative 3 times x gives us negative 3x. And negative 3 times negative 5 gives us negative 15 is equal to negative 15. So 5 minus 3 is 2. So x squared plus 2x minus 15 equals negative 15. I'm going to add 15 to both sides. I'm going to get x squared plus 2x is equal to 0. I'm going to factor out an x, and I'll be left with x plus 2. When a number or letter is outside of a group, if you distribute, you'll get the previous term. So now I'm factoring out. Now I set x equal to 0, and then I set x plus 2 equal to 0, and subtracting 2 gives me x equals negative 2. So now I have two answers. But just like with systems of equations, I have to make sure that it works. So I'm going to stick in 0 minus 3 times 0 plus 5. And negative 3 times 5 is negative 15, which equals negative 15. And now for the next one, I'm going to stick in negative 2 minus 3 and negative 2 plus 5, which gives me negative 5 times positive 3, which equals negative 15. Negative 15 equals negative 15. So my point of intersection, my solution is 0, negative 15. And my other point is negative 2, comma, negative 15. So there we go. 2 points of intersection. Okay, looking at problem 4, what are the x-intercepts of the graph of y equals this? So set your each factor equal to 0. Subtract 7, 5x equals negative 7. Divide by 5, x equals negative 7 over 5. I got 2 with negative 7 over 5, so let me get to the next one. 2x minus 1 is equal to 0. Add 1, 2x equals 1. Divide by 2, x equals 1/2. C is the only one because A had negative 1/2 and we got positive 1/2. So with multiple choice, you only need to go as far as where you agree with the answer. So hopefully that makes sense. And all you had to do with the last one was switch the sign. X equals positive 4. Okay, looking at the graph, my intercepts are negative 2. My intercepts are negative 2, positive 1, and positive 4. To go from an intercept to a factor, you had to switch the sign. So that's x plus 2, x minus 1, and x minus 4. So which one matches? X minus 1, x plus 2, x minus 4. C is the one that matches. Okay, so what I'm going to do here is I'm going to spend a little bit more time explaining this one. What I'm going to do is distribute these terms. So I get negative x cubed plus, not plus, I'm sorry, that's a negative out front, minus x squared. Okay, so now I have it in standard form, not factored form. So my leading term is negative x cubed. That tells me it starts high and ends low. It's at negative xi, it starts high and ends low. Now, for the x-intercept, I set each factor equal to 0. Negative x squared equals 0. Well, we divide by negative 1 on both sides. To get x squared equal to 0, let's take the square root. The square root of 0 is just 0. Is 0. Take x plus 2, set it equal to 0. Subtract 2, subtract 2. X equals negative 2. That's my next x-intercept. Now, for the y-intercept. X is at 0, so 0 times 2 is 0. So my y-intercept is 0. So what does that tell us? I'm coming through the origin. My x-intercept is 0, my y-intercept is 0. And then negative 2. I'm starting high and I'm ending low. So I'm doubling back on myself. So I'm starting high. I'm going to double back and I'm going to look something like that. Now, what you can always do is graph this function and it should look something like that. Okay, for the final question, the graph of a polynomial is shown. Is the degree of the polynomial odd or even? The degree of the polynomial is even. How do I know? They end in the same spot. If they end in the same spot as even. What is the constant term of the polynomial? We know that the constant term is the same as the y-intercept. So the constant term equals the y-intercept, which equals negative 4. And we didn't ask about the x-intercepts at all. But if they asked us about the x-intercepts, we're at x equals negative 2, x equals negative 1, x equals 1, x equals 2, and x equals 2. If we were to change these into factors, I would have x plus 2, x plus 1, x minus 1, x minus 2 in order. Because I switched the signs on each of the factors. Remember, you had to switch the sign for it to be equal to 0. Once it's equal to 0, it's a factor. And that concludes our practice problems for this lesson.